You two need to get used to using this, all right? It's not that difficult, is it?
No, you're fine.
No, it's dead easy. There's helmets. While you're practicing that, we'll build something.
The plan will allow Keith and Rosie to head to the remotest of beaches. A bicycle-powered generator for two. To produce electricity, they're going to make use of the curious fact that an electric motor, like the one on this scooter, can also be used as an electric generator. Generally, with motors, you put electricity in and get movement out. However, you can actually turn that idea on its head and put movement in and get electricity out. It's all hands to the pump building the bicycle generator. Keith's putting stunt pegs on the tandem. Rosie's preparing the frame to be welded by Jem, while Dick gets his teeth into any metalwork that's going. And in no time at all, it's ready to test.
Sorted.
For the moment, they're connected up to a small bulb.
Rosie, you know the rotor. It's your turn tonight. Yay! Rosie!
Rosie, we're putting a cup of tea on. We won't be long. Keep pedalling.
Almost everyone can enjoy caravan illumination.
Rosie!
Dick and Jem have now got their hands on the piece of precision engineering that is a Wells turbine.
It's got the perfectly symmetrical aerofoil. The air gets sucked up, gets diverted by the wing and sent back that way, which pushes it forwards. And then when it comes down, it hits there, gets diverted round and keeps pushing it forwards.
The aerodynamic blades on the Wells turbine mean it only spins one way, even if the wind direction changes. This is a snapshot of a spinning blade, with wind coming up from the bottom. The blade divides the airflow disproportionately, so most of it travels back along the underside. Because only a small amount of air goes up around the front, the blade is pushed forward. If the wind in the pipe then changes direction, the top of the spinning blade now experiences the disproportionate flow. The turbine will continue to spin without stalling, generating electricity continuously. What's also useful is the turbine's close fit inside this tube.
With turbines, obviously, like, if they're close to the edge, they're very good. If they're pretty much touching the edge, they're brilliant.
Jem sets to work modifying their generator so the Wells turbine will fit onto it. Dick's devising a way of mounting the turbine and generator in the yellow tube.
Let's go and fit it in the pipe.
It doesn't appear with it.
It's time to fit the Wells turbine and generator to the funnel. This is a make or break moment. Will the airflow spin it up or blow it off like a cork? The Atlantic swell around the bottom of the oscillating water column should be enough to send a powerful wind whistling up the tube. So everything's resting on whether the Wells turbine will do its thing.
Let's get it on there.
The moment it's on, they can hear it working.
Wow. Ooh,
Get it attached, Jem. I'm holding it in a minute.
All right.
Right side one now.
If I slacken this up a little.
It's breathing away.
It sounds like a sleeping dragon, like some Irish sea dragon, and every now and again, it's going to wake up like this when this comes in.
What do you think it is? Oh, it's humming.
Oh.
I think it's purring. It's
Is it?
content.
Yeah.
It's doing what it's supposed to do. Harnessing the waves.
See, it does keep going the same way regardless. I love it.
It's a success. No matter whether the air is sucking or blowing, the turbine keeps spinning. And they're also impressed with the amount of wind coming up their column.
I happen to have an anemometer for measuring the speed of the wind. Here we go.
What sort of wind speed do we get?
Up there.
26, 30! 30 miles an hour. 30 mile an hour wind through there's good.
So with the electricity flowing out, they waste no time connecting it up to a battery system. A gadget called an inverter will step up the battery output to mains voltage. And everything's enclosed in a tough weatherproof box to protect the electrics from the elements. The power will travel down a chunky cable all the way to the caravan, where surfers Keith and Rosie are eagerly waiting.
Oh, they're looking chilled. Here we go.
Oh,
Put a connector on this, connect it up. You got wave power.
yeah.
Happy days.
And once you're plugged in and the batteries are charged, it'll be lights, music, action.
Which on is next, but only after a good few hours of battery charging. As the sun goes down, it's time to get ready for the test.
We're on the case. Pull your way, Jem.
Yeah.
The moment of truth. Will the oscillating water column have produced the goods?
We've now got power at the end of this cable.
Is there enough juice to light up the caravan?
Do you reckon it's going to work?
Yes, I reckon it will. Get it in there, Dick.
Here we go. This guy goes in there like.
Oh.
Here we go.
You haven't left the gas on, have you?
It's a fantastic success. In just a few days, using some old sewage pipe and some makeshift materials, they've harnessed the Atlantic and turned its waves into mains electricity.
Here's to Irish waves.
Today it's a caravan, but tomorrow machines like this could really catch on and generate power for coastal communities all over the world. Another job well done for the Planet Mechanics.